If knowledge is a power, then learning is a superpower. These words by Jim Quick emphasize the importance of acquiring knowledge. Yet, they are rarely quoted in the embedded AI community. In fact, edge learning, or in other words, training on device, is not something that is typically recognized as a superpower. So let's see whether with this talk we can change this perception. My name is Vera Serdiukova, and I've been building products with edge learning capabilities since 2014. I have witnessed companies burn millions of dollars on edge AI with a zero return on investment, as well as edge learning revitalizing products and businesses. So today, I will share my insights on how to derive business value from learning at the edge. Learning at the edge is a topic that deserves a summit of its own, but we only have 20 minutes. So today, we'll focus on 3 points: goals, fit, and execution. By the end of this talk, you will know how to decide whether edge learning is a good fit for your needs and how to make it a success. But before we move on, let's make sure that we are on the same page and clarify the definitions. For this talk, we define an edge device as a device whose compute, memory, and energy resources are constrained and cannot be easily changed. And by learning, we mean training of a machine learning model on the constrained resources of the device. To a man with a hammer, everything looks like a nail. Unfortunately, this old adage describes a large portion of decision-making in tech. Solutions looking for a problem. I could go on a sales pitch touting learning at the edge as a panacea for any tech or business problem. This could make me look more visionary, but would be less useful for you. So instead, I want to show you how to avoid a technology-first approach and actually extract some business value from edge learning applications. First, start with the goals. These days, edge learning is still a risky endeavor. As a trailblazer, you will have to heavily invest in building conceptually new AI solutions, navigating extremely complex confluence of hardware and AI, and launching products where mistakes cannot be solved with simple software bug fixes. The investment is substantial and very risky, so you better have a good justification for it. What do you want to achieve? What business challenges is your organization or product facing? So now that we're clear that the why or the business goals should be identified first, the question is, can learning at the edge help? Those of you who did not get their coffee yet just gasped no. For the rest of us, let's see. For the past few days, we've been praising Edge AI for its fast and secure operation, non-reliant on network connectivity, as well as the ability to improve over time based on the unique user data. For learning at the edge, all of this except for perhaps speed are valid. Some would argue that all of these benefits can be achieved through other, more mainstream techniques. For example, your application can provide personalization by learning user preferences on the cloud and thus evolve. True. That brings us to my point, that the superpower of edge learning lies in the combination of these benefits. As a result, you can shape a pretty unique value proposition, a product capable of adapting to the distinct and evolving user, device, or environment data locally, with private data never leaving the device. An example of a real product tapping into this superpower is Android's adaptive battery. This battery management tool learns individual app usage behavior and limits battery usage for little-used apps. Overall, it securely leverages unique and private user data to improve device performance by extending the battery life. All right, the benefits of learning at the edge sound fantastic, but are they feasible? let's talk prerequisites. What has to be in place for the learning capability to function? To make it a bit more visual, let me sketch a basic machine learning pipeline. Essentially, gather data, train the model, make prediction. It's a very crude representation, but it will help us identify the key ingredients needed for learning at the edge, namely data and resources. Typically, model training happens in the cloud or on-prem. Oftentimes, the data comes from multiple users and it can be pre-processed, while the compute, memory, and power are expendable. It's different for the edge. So let's start with the data. Model is only as good as the training data. This overused but true statement emphasizes the importance of quality data that a machine learning model can understand. When it comes to on-device training, there are 4 big data-related challenges. First, unavailability of the individual user device data. So there is just nothing to train your model on. For instance, the device might not have a camera to capture necessary image data, or a user might not be willing to do so. Second, limited size of the data. Since a single user or device is likely to produce significantly smaller data than the one typically aggregated from multiple users. Third, data preparation might be impossible or highly constrained. With training at the edge, data does not leave the device. Consequently, we have very few means to prepare it. Ultimately, for the same reason, we might either have no label data at all or have to design elaborate ways to acquire it. For example, by incorporating human in the loop. Similar to data, resources are critical for training. For physical devices, form factor, as well as cost considerations, define and limit the horsepower. Model training tends to be significantly more demanding than inference. And as you have noticed during this summit, while specialized edge inference hardware and middleware are emerging, dedicated edge training solutions are in their early infancy. So how do you go about these 2 prerequisites of learning at the edge, data and resources? The answer is there are 2 scenarios. I call the first scenario the unicorn scenario because it is as rare as a unicorn. Here, you get to build your entire stack from scratch and thus accommodate the most sophisticated AI capabilities. The second scenario is like a black box. You inject your learning capability in. Essentially, you enable an existing product or device with an edge learning capability. The reality is, this is not a binary situation. Most likely, you will find yourself somewhere in between the scenarios, and thus have to adapt to the pre-existing prerequisites and build solutions to fill the gaps. So let's see what the financial implications of this are. In the first scenario, where we build from scratch, the cost of parts and materials suitable to accommodate edge learning capabilities is a significant consideration. And of course, you will spend quite a bit actually building a solution, as well as bringing it to the market. In the second scenario, either building a software solution for a target device or repurposing the existing one for the edge might require a noticeable engineering effort. Similarly, you will need to ensure overall product robustness and usability following the integration of edge capabilities. This should give you a rough idea of the costs entailed by edge learning, but to be clear, this is not an exhaustive list. The actual cost distribution will, of course, depend on your specific solution. However, the costs I cover here tend to be common across various product categories. So the question is, does it make sense? Is the value we get from applying edge learning adequate to our goals? The answer to this question lies in the delicate balance between three factors we have discussed: edge benefits, prerequisites, and costs for your specific application. Now that we have discussed how to evaluate edge learning fit against our goals, let's see how we execute. And we'll start by looking into some of the key aspects of building an edge learning solution. First, you need the data to learn from. As a reminder, edge learning applications tend to be constrained by limited data of an individual user or device. So your first objective is to build channels to acquire quality data and potentially inform the user about using it for a specific purpose. Here, you might also leverage users' help actually preparing the data. Let's review an example. AppLock is an authentication and authorization app that employs face and voice biometrics. Here's how it obtains user data required for training. First, it instructs the user on the conditions necessary to collect quality data, such as background light and noise level. And then it guides the user through the enrollment process to collect the voice and image data. Other than my passport photo, this is perhaps the worst picture of me ever taken, but importantly, it is good enough for the model. The next building block of edge learning pipeline I want to touch upon is the actual training. Broadly speaking, there are three key approaches to it. In the first, the most typical approach, you pre-train the model in the cloud and then tailor it to the unique user data by retraining on device. I would say at least 80% of the edge learning products we see on the market are using some variation of this approach. For example, you might remember Apple introducing this capability in their Core ML3 last year. An interesting challenge typical for this approach is handling post-deployment model updates. Once a pre-trained model is deployed on user device, it adapts to user data. However, eventually, you might want to update the initial generic model to account for the new data. So the challenge is twofold. One, how do you ship a new generic model to edge devices, some of which might be offline? And two, how do you retain customization that had been built on top of the old model? Obviously, the solutions would vary depending on the application. The second approach to training at the edge employs collaborative learning, like, for example, in the case of Gboard, that relies on federated learning to learn from individual keyboard usage on multiple devices to ultimately improve a shared model. Finally, the third approach strives to implement all of the training exclusively on the target device. An inherent trade-off of this approach is knowledge silos. Since the model is likely to be trained only on a single user or device data, it might be rather skewed. In general, this technique tends to be extremely computationally intensive. And in fact, I'm not aware of any products on the market employing this approach. If you know such cases, please reach out to me after the presentation. Before we wrap up, I would like to briefly mention a few additional considerations related to building edge learning capabilities. First, designing for a potential model loss. Imagine your app has been building these private personalized models stored on device for months and years, and then boom, the device breaks down, taking the model with it. Or your user forgets the device, say smartphone, in a bar and never sees it again. Or the user just updates the device and your model either cannot be transferred to a new device or does not function properly on a new hardware. The possibilities are endless. So it is really crucial to prepare for such possibilities. Second, ensuring user experience consistency. Edge learning allows us to provide unique experiences for every user, device, environment, as well as combination of such. However, if the learning happens privately and locally, how do we maintain user experience consistency across multiple devices, for example? This is a really fascinating problem to solve. The third consideration lies in a quality assurance space. As the model evolves locally, how do we ensure that it actually improves, functions properly, and ultimately meets user needs over a product's entire life cycle? Overall, when it comes to execution, there is no playbook for edge learning. Every stage is fascinating, yet not trivial. From identifying data sources available to performing on-device training to finding the ways to monitor evolved models, it is going to be an adventure. Therefore, it is incredibly helpful to start by assessing whether edge learning is a good fit for your goals, as opposed to executing headfirst. And here we are. We have discussed how to derive business value from learning at the edge by clarifying the objectives, assessing the fit, and ultimately building edge learning solutions. One thing to remember, this is not a linear process. As your priorities and business circumstances will be changing over time, in order to focus on the actual business value, you might need to reassess these three elements. Edge learning is a powerful tool that can help you shape a radically new value proposition. A product capable of adapting to the distinct and evolving user device or environment data locally, with the private data never leaving the device. However, unless you're deliberate in applying it towards specific business goals, it can easily turn into a new hammer looking for a nail.